Okay, cross country kids, we are on the review. We're on number 25. We've got 6 problems to go, and then I gave them an extra sheet of paper that looks like this. That's the second half of the review. It's not the second half, it's like the last 25%, okay? Because it's a little bit shorter. But yeah, here are the surface area volume problems. That's where we're at. Okay, what is the shape? 25. A cone. We need surface area and volume of a cone. These I will not expect you to memorize. I will give these formulas to you. Okay? But I don't have them. Jace, you've got your book right there. Let me see. You got your paper for surface area? Oh, awesome. Zach's going to give them to us. Perfect. Thank you, Zach. Okay, cone. Zach, what do we got for surface area of a cone?
Pi r the curly L
Okay.
plus pi r squared.
Okay, write these down. Pi r L plus pi r squared. Volume? 1/3? I don't remember. Pi r squared h. Okay. All right. We only have 3 variables going on here, right? We have an r, we have an L, and we have an h. Okay, let's define which ones are which. What is r? Radius, which is 4 in this case, right? 8 is the diameter. Okay. What's the difference between L and h?
H is the slant height.
Nope. Other way. L is the slant height. I can remember that because the L is cursive and it's slanted. Okay? So L is slant height. L is 12.6. H is 12. Okay, now we're plugging stuff in. So I have pi times 4 times 12.6 plus pi times 4 squared. Now please try to do some of this without do some of this in your head. Like rather than typing in 4 squared in my calculator, I'm going to type in 16, right? Like do some of the work in your head to make it go faster, okay? So we're doing pi times 4 times 12 plus, you should just be able to type that all in. If I were you, I would practice typing that in. Pi times 4 times 12.6 plus pi times 16. I got 208.6. Is that what you said, Trevin? Okay, surface area is this is in feet what? Squared for surface area. All right, volume. 1/3 pi times the radius squared, which is 4 squared, times the height, which is 12. So I've got 16. Oh, check this out. Wait a second. 4 squared is 16. I can take 1/3 of 12 really nicely. Yeah? That is 4. Can you take 4 times 16 in your head? 64 pi. That sounds like a lot better to type in than all the other junk, right? 201.1. Yep, 201.06 or 201.1. And that is in feet cubed. Perfect. Okay, a sphere. We got surface area and we got volume of a sphere. Okay, surface area is
4 pi r squared.
4 pi r squared. And volume is 4/3 pi radius cubed.
Yep.
Perfect. Okay, what is the radius? It is exactly 5.1. It's not anything else. So I'm going to put 5.1 squared in there times 4 times pi. If I were you, I would practice typing this in. I got 326.9. And that is that meters?
Yes.
Meters squared for surface area. Okay. How do you do 4/3 in your calculator?
You put in the fraction,
I do 4 divided by 3,
or you can just get it.
right?
Yeah.
Or you can do whatever you want. Yeah, sure. I'm going to do 5.1 to the 3rd power times pi times 4 divided by 3. I got 555.6. Is that true?
Yes.
Perfect. Meters cubed. There you go. Okay? All right. Cylinder.
Can you slow down?
Yep. Can you go faster?
I tried.
Just kidding, Kellen. What's the surface area of a cylinder?
2 pi r h plus 2 pi pi r squared.
Okay. And volume of a cylinder is the same as volume of a cone, but no third.
Why don't you
Pi r
do-
squared h.
Why don't you just do diameter times pi times height, and then
You can.
pi r squared?
Right, right, right. Something like that, sure. Whatever. Whatever. We only have two variables going on. We have an r and we have an h. R is 7.5, h is 15. That's it. Okay? I'm going to plug in 7.5 here. I'm going to plug 15 in here. I'm going to plug 7.5 squared in here. And all of the things, right? Actually, well, whatever. Maybe. Maybe. 2 times 7.5 times 15 times pi
You get 1060.
plus 2 pi
I was gonna say,
7.5 squared. 1060.3? Woo. You did it wrong. 1060.3 inches squared.
2,650.
Plus 2 pi times 7.5 squared.
150.
Pi times 7.5 squared times 15. Did you get it? Pi times 7.5 squared times 15. This one I got 2650.7. Is that true?
Yeah.
Perfect. Okay. You're just using the correct formula, plopping the numbers in, doing all the things in your calculator correctly. Everything. Okay? Beautiful. Can I go on to the next? What? No? Okay. Okay. Allie, can I go? No. No. Okay, good? All right, what's 28?
Rectangular prism.
It is a square pyramid. Okay, surface area of a pyramid. What you got? Yep.
1/2 the cursive L plus B.
Okay. Volume?
1/3 the H.
No.
Only the first ones.
Okay, what does capital P stand for?
Perimeter.
The perimeter of the base. That's why it's a capital letter. You got to do perimeter of the base. The base is this thing, 18 by 18 by 18 by 18. If I'm finding the perimeter,
Multiply 4 by.
you're taking 18 times 4, which is 72. Okay? Yeah.
D is gonna be the area of the base.
Okay? L, what's L? What's the slant height here?
It's going to be
16. Okay, what does capital B mean?
area of the base.
The area of the base. The base is a square. How do I find the area of a square?
Square, the thing squared.
18 squared, which is something.
324.
324. Okay. I know that half of 72 is 36, and 36 times 16 is smaller. Whatever that is. 36 times 16 is 576, and then I add 324. And that is 900 feet
900 where?
squared.
I'm so
Can you do
lost.
that one more time?
So 1/2, capital P is the perimeter of the base. So it's all of these added together. 18, 18, 18, 18, which is 72. The slanted height is I don't know if you can see this very well. Slanted height is 16. And then capital B is the area of the base. So it's 18 by 18, 18 squared, which is 324. And then I just take and multiply them. So 1/2 times 72 times 16 plus 324
What
is
would you consider
900
one of the perimeter sides?
feet squared. What?
What would you consider one of the perimeter sides, or like one of the sides that measures 18? What would that be considered as like? Width?
Length and width.
So that'd be width side?
What?
18.
This I would say is the width. This is the length. And 13.2 is the height.
Okay.
Yeah.
So does that mean
Yeah.
that,
Yeah.
that
Correct.
every spot on the side is the same distance from the middle, or no? So like the corner's the same distance from the middle as like the middle of the right side. Do you know what I'm saying?
No. Say that again.
So you have the middle, and then you have. So if you have the middle,
Mm-hmm.
it's not the same distance from here to here than it is from here to here.
Correct.
It's two
It's
different.
shorter distance from here to here, but it's the same distance here to here as it is here to here, and here to here, and there to there. And each of these corners are the same distance.
So how would you know what the distance of this is?
Actually, it's Thursday.
What?
So how would you find the distance from here to here?
From where to where?
The bottom to the top corner.
To the top corner?
Yeah.
Okay, you could do it by using the Pythagorean theorem. So like we know that the slanted height right here is 16. And we know this top guy right here is 9, right? Because it's half the distance. And 16 and 9, you could do the Pythagorean theorem doing that. Same thing if we didn't know what like the inside height is, because I don't know what I can't shove a pole down the center, right? I don't know what this guy is, but I do know that from here to here is 9, right? And I know this slanted one is 16, so I could find that
Okay.
height as well, right?
Thank you.
Okay, yep. Okay, all right, moving on. Volume, 1/3, capital B. What's capital B mean? Area of the base, 18 by 18. We already know the area of the base is 324, right? What's H? 13.2. Okay. I can take 1/3 of 324 in my head. Can you take 1/3 of 324 in your head? 108, right? Do that in your head, and then just take 108 times 13.2 in a calculator, right? You can do that in your head, right? Do as much in your head as you can. Not that part in your head, Ella, but like the 324, 1/3 of 324. What do you get?
That just leaves room for mistake.
No, what?
1425.6.
1425.6, and that is in feet cubed.
Are they changing the schedule tomorrow?
What? I have no idea. I don't know anything. I'll look and see if I got an email at the end of the period.
What's
I don't know.
tomorrow?
Tomorrow they're decorating for homecoming
Oh,
and
yeah.
doing tapping ceremony and all the things, right? All right, 29. What is that? That is a rectangular prism. Blech. Rectangular prism. Surface area. Go, Zach. Rectangular prism.
Oh. PH plus 2B.
Okay, volume.
BH.
Capital BH. Okay, are we ready for this? The bottom. Is the bottom the base? It doesn't matter in a rectangle. You can decide. Should we just say the bottom is the base? Okay, so if this is the perimeter, you got to listen. Shh. If P is the perimeter of the base, we've got 7 by 3 by 7 by 3. What is that?
It's the surface area.
20 is capital P. Okay, what's H? 4 plus 2. What's capital B mean? The area of the base is capital B, and that is 21. You can do this in your head. Everything you can do in your head. What's 20 times 4? 80. What's 2 times 21? 42. What's 80 plus 42? 122 yards squared. Okay? Capital B times H. Capital B is the area of the base. The area of the base is 7 by 3, which is 21. The height is 4. You can do that also in your head. That is 84 yards cubed. Is it true that the surface area or the volume is always bigger than the surface area? No, this is a waste of materials. If I was creating a box,
Not necessarily.
it is not holding very much.
But
right? If you want to optimize this volume, you want to have your surface area be smaller than your volume, right? Like this is like a waste of cardboard. Does that make sense?
How does that even work?
So like when we get to like trig and calc, we start talking about like optimizing. So like what would your dimensions have to be in order to get the most bang for your buck, right? Like to hold the biggest volume, okay? And did you know that if you want to hold the most volume, you are going to make sure that that object is the, the most square. Right? Okay, just think about it as in terms of perimeter, right? If I have 100 feet of fence, I could make my fence go 1 by 49 by 1 by 49. That's 100 feet of fence. But what's the area of that?
49.
That is 49 for an area, right? Or I could go 2 by 48 by 2 by 48, right? Now my area is 96. Okay, what's going to be the most bang for my buck?
10.
If it's 25 by 25 by 25 by 25, because 25 squared is like way bigger.
Well,
Is it
actually,
625?
It's not necessarily a waste of space because if you just increase the length of all of them, then your
Well, what if you're
volume
trying to
comes
store
out to be bigger than
rectangular
the surface area.
Right,
So if you do 14, 13, and 17,
right, right,
then you get.
right, right.
But so if you calculated that same problem in like feet,
Sure.
probably come out
Yeah, right.
more bang.
Now, I'm not saying that this is bad because, like, I'm not going to send a huge box in the mail
That's a
for like
huge
one,
box.
like, well, that is a huge box, but I'm not gonna increase the dimensions just so that I'm optimizing my space when I don't need this space, right? Like if I'm only sending a small thing, I'm gonna only send a small box, which is gonna obviously use more surface area than volume, right? Whatever. Okay, but if I want to optimize the thing, I'm gonna make it as square as possible or as cubic as possible, right? We get to that in trig and calc. All right, moving on. 30, what is 30's shape? This is going to be the hardest one probably. This is a, what?
Triangular prism.
He's a triangular prism. What are the bases? The triangles. This is not setting on its base. The base are the front and the back, yeah? Okay, so it's the same formula as what I have over here. Surface area is capital PH plus 2 capital B. If you are not listening so far, you better listen to this one. Okay, if the base is the front and the back, I need to know the perimeter of the base. The perimeter of the base is going to be this guy, plus this guy, plus this guy. What is the slanted one? 10.4. It's the same as the back side. Okay, if I add all those together, that is how much? 24.9. That's the perimeter of the base. What's the height? 2.8 is the height. If I flip this so that it's setting on the base, the height would be 2.8, right? You got to think about this in terms of like it's setting correctly. Okay, and then 2 capital B. Capital B is the area of the base. What shape is the base? A triangle. So I need to find the area of this triangle, which is 1/2 base times height, right? What's the base of that thing? 8.3. The height is 6.2. Now, if I were to do this, I like to do whatever I can in my head. I can't take half of 8.3 very nicely, but I can take a half of 6.2. That's 3.1. So now I'm only going to take 3.1 times 8.3, and that is something.
Whoa.
8.3 times 3.1 is 25.73. That's the area of the base. Okay, now, my formula is not terrible. 25.73 times 2 plus 24.9 times 2.8. Something like this. 121.18. So 121.2 centimeters squared. Okay, volume. Capital B times H. What shape is the base again? The triangle. Have we done capital B already? Yeah, 25.73. And the height, again, is 2.8. Okay? 25.73 times 2.8. I got like, I don't know, 72.0.
Yeah, I got that too.
If it's 72.0, do you put the .0?
Yes.
Yes. yes, right? We've talked about why the 0.0 is significant. Yeah,
It's not.
it is. It's important. It's important. Okay? All right, we got a little bit left. 31.
More, you like this? Dumbest part of
Like 29, we didn't have to round any of them because they were whole numbers, right?
Well, yeah, but it says round to the nearest tenth if necessary.
So it wasn't necessary to round to the nearest tenth on number 29 because they were whole numbers.
Necessary to round to the nearest tenth.
Yes, it is on 30 because 0.0. That means because if I don't put the 0.0, then it looks like it came out evenly at 72, and it didn't. Okay, 31. Orthographic drawing is top, front, left, right. Okay, the top view. Okay, we're looking at it from this direction. The top view. Are you ready? What's the top view look like?
I don't know if I can see
It's
which angle
like
you're
5
starting at.
bucks.
This is, I'm looking at it from this way, but I'm looking down. So like my head is right here. Looking down on it, right? I'm looking at it from like this angle.
Okay.
And I'm looking down this way, right? That's my top view. Okay? So what's top look like?
2 towers.
Like that? Yeah? You see there's like 3 in the left column and 2 in the right column? Okay? But I have 1 cube that's sticking out. So I have to put a division here and a division there, right? So it looks like that 1 cube is like sticking up, right? You see that?
Front and right is not clear on this.
The front, what?
Front, it's like in between two of them. I don't know which one. Which side's the front?
Well, is the right?
Oh, the right is not in the right spot. So is this the front?
I would assume.
No, can we do it the other way?
made this.
Okay, I'm gonna, because we've already created this. Let's say that this guy is the right. The right is over here. Okay, the right is this way. The left is this way. Let's do that. I don't know why that right is all the way around the corner. Okay. All right, so the top view is correct. The front view, what's the front view look like? Like a tiny L. Yeah? Okay, but
Don't they all need one?
they all do need one. This guy and this guy both need one, right? Okay, do you see that? If I'm going in from this direction, he looks like an L because he's 2 here and 1 that way, right? Okay? But this and this are not on the same, so I need to have a line there. That's this line, right? And then this guy needs to be set back, so I have that line there. Got it? Okay, from the right view. How many do you have on the bottom on the right view? 3, and how many on the top? 1, and he's on the very right, right? That was a lot of rights. Okay? All right, where do I need to put my division line? Right there and right there. Yeah? Okay, because these two are setting out forward, right? This one's back, so I have to put a line there. This one's back. I've got to put a line there. Got it? Okay, the left side. What's the left side look like?
It's like the opposite.
Like the opposite of the right. Where do I need division lines there? Nowhere, because he's flat on the back side, right? On the left side, he's flat. Got it? Yep. Yeah? Okay, do your dot paper drawing. Yep. Do your dot paper drawing. If you need me to help you, I will come around and help you. Are you done?
Is this
Off the mark because I went too high up, but still.
Tommy, is this good?
That looks awesome. Yeah. If you it might be beneficial to shade your tops. No? Yeah, that looks awesome. Okay, anybody else? Want me to come look or help?
I like doing the drawings.
That looks good. Very nice. Very nice. I'm gonna erase though. You started erasing them, but I'm gonna erase this guy right here. Whoop. And that guy right there. Yeah. Yep. Looks good. I
How's
like
this
it.
look?
Looks great.
If I left those lines in there on the test, would you get it wrong?
Probably not. Do, 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 do.
We have to include the holes on number 33.
Yeah. Come on, Jacob, challenge yourself. Just kidding. Just kidding. I have never been asked that question before. That was quite a thing. Beautiful. There you go. Look at how fancy he is. Beautiful. Okay, anybody else want me to look? All right.
When we make the net, do we have to put the dimensions?
Yes. Yes. Sorry.
Oh, was the net where you draw?
The net is unfolded.
It's on the envelope.
What? This is the net. This one is the net. They want you to draw what it looks like if you put it back. What does this thing look like if you put it back together? It's a cone, right? Like, that's what it looks like. Okay? I know, you can't really see it very well. Whatever. What, the height of the cone is that 6.5? I don't know. And is that 4.5? I don't know. Sure. Something like that. Whatever. Okay? How do you draw your net for the cheese?
Very easily.
What?
Very easily.
Very easily. I'm going to do, this is the bottom right here, right? And let's see, this is that side, and this is that side, and this is that side. It does kind of look like a rocket. But then this is another
Can you
Yeah?
put that link that you just drew on the top of one of the
Sure.
triangles?
Yep. You can go like this. That's what you did?
Yeah.
Sure, that works. Or you can put it over on this side. Right here. Whoop. Right there. Yeah? Yeah. 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 Besides the wrong place, right? So this is 17.7. This length here is 6.4. This length here is 9.2. Yeah? All those things?
Do we have to solve for like the one edge that is not?
No. No. What did you say? Okay? Good?
Yep.
All right, beautiful. 34. Coffee maker manufacturer claims that the customer will get 48 6-ounce cups of coffee from a 1-pound bag of coffee. Okay, but 7 customers actually did this. They're like, I want to see how many cups of coffee I actually get out of it. Okay, the first customer got 1 more cup than what they anticipated, right? The second customer got 2 more cups than they anticipated. The third customer got 5 more. The fourth customer got 1 less, right? This one got 3 less. This one got 6 less. They are just drinking some strong coffee, right? Probably, right? They're just using more of the coffee grounds, probably. Okay, and this one got 53. Is the manufacturer's claim accurate? Let's talk about accurate. ACCURATE versus precise. Okay, what does accurate mean?
On the dot.
Good. What's precise mean?
The same number.
Consistent. Okay. So, is it accurate? Is it precise? Is it one or the other? Is it both? Is it neither?
Neither.
It's kind of
Kind of accurate.
It's
but-
kind of just meh.
Neither.
I'm going to say it is accurate because these numbers all overlap what the actual is, right? I have some numbers that are below, some numbers that are above. If I would average these together, it probably would be close to 48, right? It is accurate. It's pretty close to what the actual is. But are those numbers consistent? No. If they all were like 47s and 49s, I would say that's more precise, right? So I'm going to say yes, it is accurate because those numbers are on either side of the actual, but it is not consistent. What?
Average is like 44.
What? Really?
Yeah.
Because that 42 is pulling it down probably, right?
Why did you add the 53 at the end?
Yeah, did you put this 53 on there? Okay. Whatever. Okay, so that's what I would say. Yeah? Make sense? Okay, accurate is good, precise is consistent. There's a difference between the two. Good, good? All right, 35. 1 bale of cotton is represented as weighing this many kilograms. And manufacturer purchases 10 bales which weigh a total of this many kilograms. What is the approximate error? How do I do that?
Bale's approximately 2.6.
What's the approximate error? 1.4 kilograms. I just subtract them. That's the error. That's how much approximate error is how much I'm off by, right? It's not saying percent error. I don't have to do that as a percentage, right?
Your question is really.
But it's
One
one
bale of cotton
bale,
weighs 225
and there's
kilograms.
10 bale. Why you
10 bales.
Oh.
What's the
Yeah,
total
so
weight?
it's-
can have, yeah, okay.
It
They're
should
off
be
by a
2,000.
lot.
Hey. 26.
Ella, grab my pencil.
I mean, each bale only weighs like.
Oh, I think this is a typo because I changed it. Yeah, 226.4 is what it originally said, and then I read it wrong. Huh. Which means it should be 226.4. I changed it, but I shouldn't have changed it because I thought it was a typo and then it wasn't. Right? Yeah. The original, when I made this, the original said 226 or 2,264 is what the original said. And I'm like, oh, they forgot a decimal. So I'm going to put the decimal in there when I made this worksheet, right?
Yeah.
And I shouldn't have put the decimal in there, true? Okay.
Because there's 10 bales.
So, yeah, because there's 10 bales.
Okay,
I didn't realize that. So, the approximate error is still 1.4 because I shouldn't have put the decimal in there. Yeah. Because I corrected it and I shouldn't have corrected it because it was wrong. Sorry.
It could also be 14.
They're not like.
What?
It could also be 14 depending on how you do the question. Because if it's
But that's
10
when
bales
the
is the
class
one bale.
That would, no, because that would be like 14, that wouldn't be 14 grams.
450 pounds.
No? 'Cause if you-
No, because, okay, approximate error is going off of 1.
Okay.
Yes, good question. I get you. So we could say 1.4 kilograms for 1 bale or 14 kilograms for 10 bales.
I see why you put the decimal.
Yeah. I thought it was wrong. Anyway, whatever. Okay, 36. All right, 36. This one's a doozy. Are you ready?
No.
Colton, are you ready? Okay, watch. Come on, kid. The Recreation Department is planning on resurfacing one of its tennis courts as shown. The cost to have this work done is $2.80 per square foot. Circle that. $2.80 per square foot. What is the least and greatest values of the length of the court? Which one's the length, by the way? 98 is the length, okay? The way that this is written, it is measured to the nearest foot, right? 98 feet. That's 98 feet exactly. No. We measure to decimals. We don't measure to numbers. Yeah.
So did you do 97.5?
No. Whatever.
What's the number?
Well, you can measure to the nearest third,
So
too.
you are measuring.
Right? No, I don't think so. Okay. All right, so we're measuring to the nearest foot. So what is the smallest that number could have been?
97.5.
97.5, right? Okay, because if it's anything less than 97.5, it's going to measure to 97. What's the greatest it could be? 98.5. Okay, what about the height or the width of the court? What's the smallest it could have been? 55.5. What's the greatest it could have been? 56.5. Do you see how this works? Right? That's the least and greatest amount it could have been.
4 instead of 5.
What?
Why is it not 4 instead of 5?
Because anything, yeah. So technically it's like this. 55.5 is less than or equal to X, which is less than 56.5. Yeah. So it's like that. So you're still going off of the 0.5 number, but if it is this exactly, it would round to the next one. But we still use the 0.5 number. Whatever. Okay. Good? Questions about that? What is the possible range of the area of the court? Okay, so at the low end, let's say this is the least and this is the least it could be. If we are doing area, we're doing base times height or length times width. And at the very least, it's these two dimensions. If I multiply those two dimensions together, I get the smallest possible area. What?
5,411.3.
Okay.
Well, 2.5.
Okay, we'll talk sig figs here in just a second, right?
And how did you do that?
We just multiplied the smallest possible dimensions together, right? Now the largest possible dimensions are these two. If I multiply those two together, I get something else.
It's 5,565.3.
Point what? 0.3, okay? Square feet and square feet, yeah? That's that, okay? All right, now, that's off by quite a ways. That's 150 square foot, right? 150 square foot is quite a bit, right? Like, that's a discrepancy of 150 square foot just by rounding to the nearest foot. By rounding to the nearest foot, I could be off by 150 square foot. how can I make that discrepancy or that error be smaller? Round to the nearest inch, right? Or round to the nearest quarter of a foot, or whatever, right? Or half of a foot. I don't know. So that could make that margin of error smaller. Got it? Okay. What is the possible range for the cost of the court? It is $2.80 per square foot. So how do I figure this out?
5, 4, 11.
Divide this number by $2.80. Divide this number by $2.80. Tell me what you get.
Why?
Yeah.
Why?
Multiply. Because I'm just trying to see if you're awake. Yep. I'm clearly not. What?
15,151.
What?
$15,151.64.
Yep.
Whoa. 15,000 bucks. All right, there you go. Okay, on the high end, it's going to cost me how much?
15,500 something.
Yeah, it's rounded.
What?
What?
15,500 something.
0.84?
I'm not.
Okay, that's a discrepancy of about $430, right?
Hold up. Wait
That's
minute.
quite a bit of money for a discrepancy.
Oh, did you just take, Lauren, did you just take 5411.3?
Yeah, times.
Well, the exact is different.
Okay, shut up.
Okay, well, it's fine. It's fine. It's fine. Okay, that's still a pretty big discrepancy. I mean, I get that we're talking about $15,000, but
You could've
400
taken
430 bucks is quite a difference. You know, whatever. Anyway, to me it is, I guess.
Exactly 14.
Okay. So again, we can narrow that by not going to the nearest foot, by going to the nearest inch. Okay, or some smaller value. Got it? Okay. All right, here we go. Sig figs, you do these. You do these and we'll check. And then we'll stop for the day, maybe. Yeah.
Okay, I'm done.
How many sig figs? You do those 4 and then we'll check.
So we don't have a test tomorrow.
No, we don't have a test tomorrow.
Yay!
Do we have class tomorrow?
We might.
And we'll have
Are
like
you
a few
sure?
minutes of class if they don't change the
Hey,
schedule.
Calvin, did you give me some more over the intercom?
If you're the ones putting in,
Yes.
We
Okay.
know who you are.
How many sig figs does 37 have?
Yes.
They don't know. They only know. They only know for the girls.
I'm like, how are they gonna stop us?
Yeah, real.
Kellen, how are they gonna stop us?
I don't understand.
Did you get 5 through 3 1?
Yep, that's what I got.
What?
I don't understand. I got all of these right.
You did. Okay, which numbers are significant here? 602. This is just spacing the decimal. It's not significant. Neither is this one. Not significant. Because it's just spacing the decimal. Okay, now, yes. One way of thinking about it is if I were to put that number in a scientific notation, I would put 6.02 times 10 to the negative second power. All this 0 goes away and this 0 goes away when I put it into scientific notation, right?
Yeah.
This guy,
Do it like that.
40, if I put this number into scientific notation, it would be 1 times 10 to the third. This goes away, this goes away, this goes away, right?
If there was a behind it.
If this was 0.0, then that would be 5 numbers significant. Yeah.
Technically, it's valid. Did you make you a national?
Okay, there you go. One number. All right, all done.
She said, my sweet boy.